So my topic is that one, making Indian cities smart through climatic adaptive infrastructure. So first of all, let me start with the reality. What Indian cities are facing today? Okay, Indian cities are experiencing multiple climatic stresses at once, like heat, floods, water stress, air pollution. These are not the future risks. They are current operational challenges. Urbanization is accelerating. Infrastructure decision today will last 30 to 50 years. When we talk about the making Indian cities smart, the conversation often begins with technology, sensors, command centers, data platform. But in reality, Indian cities today are struggling with far more fundamental challenges like extreme heat, flooding, water stress, air pollution, and infrastructure overload. A city cannot be considered smart, if it fails under climatic stress. Indian cities are growing rapidly, and this growth is happening at a time when climate risks are intensifying. Infrastructure choices made today, road, drainage, transport corridor, land use will define whether cities remain vulnerable or become resilient for decades to come. Therefore, making cities smart must begin with a shift in thinking from short-term efficiency to long-term resilience, from isolated project to systematic planning, and from technology first to infrastructure first strategy. A smart Indian city is not one that only respond faster, but one that fails less often. We can take example of the heat waves in central and southern Indian cities, flooding in the coastal and plateau cities, groundwater depletion across Tier 1 and Tier 2 cities. What we build today will decide whether our cities struggle or survive tomorrow. So one of the biggest structural problem in Indian cities is a silo-based planning, like roads, water, energy, waste planned by the separate departments. Climate impacts expose the weakness of this approach. Flooding disturbs transport, heat increase energy demand, and waste affect the water. Most Indian cities still plan infrastructure in a departmental silos. Road without drainage integration, water projects without land use control, and smart technology without governance coordination. Water transport, energy, waste, and housing are planned independently, often by different agencies with limited coordination. While each system may work in isolation, cities fail at their points of intersection during floods, heat waves, or infrastructure breakdowns. Making cities smart requires systematic planning. We should understand very clearly, flooding is not just a water issue, it's a mobility issue. Heat stress is not just a climate issue, it's an energy issue. Waste is not just a sanitation issue, it's a land and health issue. Smart nets emerge when infrastructure systems are planned together, especially functionally and institutionally. Integration, not automation, is the foundation of smart urbanism. Let me explain this integration through real infrastructure stories. Water is one of the clearest example of why integration matters. Lakes were historically floods, buffers, and climate regulation. Many lakes projects fail because they focus on the beautification, not on the stormwater networks, catchment management, sewer separation, and public realm design. Water is central to the idea of smart cities in India. Traditionally, lakes and water bodies were part of the interconnected urban system. Over time, they were reduced to isolated features or treated as beautification projects. This approach has proven insufficient under climate stress. When lake rejuvenation is integrated with stormwater networks, groundwater recharge, sewer management, public realm design, lakes become flood buffers, cooling system, and water security assets. A smart city does not fight water, it designs with it. Water sensitive urban design is one of the most cost effective and climate resilient strategies available to the Indian cities. In several Indian cities, once lakes were linked to drainage and land use planning, flooding reduced and groundwater levels stabilized. However, when lakes were integrated with catchment level stormwater planning and road and land use design, they begin functioning as flood buffers, cooling system, and water security assets. Okay, and we should understand a lake is not a landscaping project; it's a climatic infrastructure. The same integration applies to the transport and energy. Transport decision quietly shapes a city's climate footprints, and transport is a major source of emissions and heat. Road expansion also increase demand and congestion. Okay. Integrated approach like public transport, compact mixed-use development, EV infrastructure, and renewable energy and smart grids. Mobility is often where the idea of the smart cities become visible, but also where mistakes are most common. Making cities smart most means reducing the need to travel, not just making travel faster. And this is the basic mistake which we are doing right now. When land use and transport are planned together, cities consume less energy, emit less pollution, and become more livable. Urban form itself become a climatic solution. Cities that align transport corridor with highly density mixed-use development achieve it to lower per capita energy consumption, reduce dependence on private vehicles, and improve viability of electric mobility. When EV charging was linked with renewable energy and smart grids and demand management. So, cities that adopted transit-oriented development principles saw lower per capita energy use and better public transport viability. So, we can say the greenest energy is often the energy we never consume. Okay, and in my this slide, I am discussing about the culture, corridor, and governance. Some of the most powerful integration examples come from the cultural and corridor projects. We can take an example of the Kashi Vishwanath corridor, Ujjain Mahakal Mandir corridor. Okay, these are the religious projects, but actually they are improving the pedestrian system, crowd management, drainage upgrade, and public amenities and local economic activation. Smart cities are not only about the infrastructure, they are about governance and cultural context. Temple corridors and grid-based infrastructure projects demonstrate how Indian cities can integrate cultural heritage and local economics also. These projects succeed when multiple agencies work within a shared spatial framework. The real intelligence lies in the coordination, not technology. Making cities smart requires strong institutional alignment. Governance is the invisible infrastructure that determines whether a smart city project. So smart cities fail not because of the lack of data and lack of coordination. My last slide is that one, if we step back and look across all these examples, then lakes, transport, corridor, grids all succeed when integrated, and integration across. So basically, if we step back and look across all these examples, okay, so lakes, transport, corridor, grids all succeed when integrated, and integration across systems, departments, ecology and engineering, culture and infrastructure. So what truly makes an Indian city smart, which means not dashboard alone, not censored alone, and not isolated pilot projects. Okay, so a smart Indian city is one that integrated infrastructure systems, anticipated climate risk, adapts to uncertainty, and recovers quickly from shocks and serves all citizens, not just